Hello, ladies and gentlemen. This is Mr. Green, and this is another in our series of Algebra 2 lessons. So here we go. Where should you be? Well, remember, we got due dates. Due dates come up 28 days later. I have to close the items out, and we can't reopen them. You need to make certain you're getting those things into me. The zeros are really hurting some people's grades, so you want to make certain you get those things taken care of. What I'm going to be looking at today is lesson 4 in unit 7. This has to deal with graphing radical functions. So we're going to draw and describe the graphs of radical functions and determine the domain and range of some radical functions. So if we're looking at a radical function, we're looking at some variable a times the radical to the nth power of x minus h plus k. What is that? That is the general formula for a general radical equation. If n is an even number, it looks like this one right down here. Okay, that's the parent function for it. Okay, because this is x to the nth power where n is an even number. Okay, this is actually the square root of x. You can see right here. But x to the n looks like this. So this is the generalized equation. What do these things do? Remember, the a is an amplifier. It makes it get bigger or smaller. The x is a shifter, makes it go left and right. And the k is a shifter, making it go up and down. Okay, that's where these three variables come into play and cause these things to cause changes in the square or in the radical equation. Okay, so we're going to look at a couple of things. First of all, let's just try graphing the square root function. Well, if you put values in for x and get the resulting values out for f of x in a square root function, 0, 0 is 1 point, 1, 1 is a point, 4, the square root of 4 is 2, so that's a point, and the square root of 9 is 3, that's a point, and we could go out to 16 if we wanted to, but we can't really get it on the graph here. So basically, it's not a straight line, it is a curve that looks something like that. And I am a really bad drawer of this curve, but it looks something along that lines. Okay, so that's generally what it looks like. Okay, what is the domain? Domain is the same thing as it always is, x values. Well, since we can't take the square root of a negative number, the domain in this situation will be x is greater than 0. Why? Because if it is equal to 0, well, greater than or equal to 0. If it's anything less than 0, it would be negative, and we can't take the square root of a negative number. My range is also going to be values of y greater than or equal to 0. Why? Because you'll never get a negative number when you take the square root of something. Okay? So let's move forward just a little bit forward in the slides, and let's do the x cubed function. Well, on the x cubed, 0, 0 is also a point on it. 1, 1 is also a point on it. If I go to 8, let's see here, 2, 3, 4, 5, 6, 7, 8's right there, and it would be at 2. And 27 would be, when x is 27, it would be 3. Well, you can't get out that far. But negative 1, 1 would be a function. If I take the cube root of negative 1, I get a negative 1. If I take the cube root of negative 8, I get, move up just a little bit there, graphing tool, thank you. If I take the cube root of negative 8, I get negative 2. So what does my function look like here? It looks like this, coming in from the left, comes in like that, makes a little curve, and goes out to the right, like that. Okay? What's my domain in this situation? Well, I can use all real numbers in this situation because there's nothing preventing me from having a negative or a positive. And my range is going to be all real numbers again. Okay? So we've got values for both square root and cube root. Well, I want you to look at them real closely. Square root, cube root. The square root and the cube root are not a whole lot different. The square root would be actually just a little bit higher on here than the cube root, but it's not going to go over here on the negative side. The cube root has this negative side on it. So you can tell them apart without any difficulty just by looking at them. Like I said, the h and the k are shifters. If you look at the a value, you see how if I use an a of a 2, how it causes it to amplify out. It goes from this value right here up to this one up here. And if its a is less than 1, it goes down like that. That's an amplifier, as I call it. And if it's negative, it would cause it to actually shift down here, right? Well, if you look at the the y out here at the end, the k being added on at the end, I'm calling it y, but it's what it's doing. It's causing it to shift up and down. So if I add 3 onto it, it moves it up here to 3. If I subtract 2 from it, it comes down here to 2. Okay? The h is what's causing it to move right and left. If I add 4 onto it, it moves over here to the 4. If I subtract 3 from it, it comes over here to the negative 3. Those are the way the shifters work on this graphing. So if I'm given an equation, wanted to look at the cube roots. Since cube roots are slightly different and they have tails on both sides, the A works the same way, shifters causing it to, or amplifier causing it to go up, shifter down, shifter right and left. They both all work the same way. It's just a matter of cubic or square roots. Okay? So let's look at a couple of problems here. If I'm given something like this, where it says negative 3 x plus 1 minus 2, we want to graph that. I think the easiest way is to stick some values in for x. If I stick a negative 1 in for x, I got negative 1 plus 1. That's 0. 0 times anything, 0 minus 2. Minus 2. If I stick a 0 in for x, 0 plus 1 is 1. Square root of 1 is 1. So I've got a negative 3 minus 2. That's a negative 5. If I stick a 3 in for that, 3 plus 1 is 4. Square root of 4 is 2. 2 times negative 3 is negative 6. Minus 2 is a negative 4. Okay? If I stick an 8 in for x, 8 plus 1 is 9. Square root of 9 is 3. 3 times negative 3 is a negative 9. Minus 2 is a negative 11. So we've got some points. At negative 1, it's at negative 2. At 0, it's at negative 5. 3, 4, 5. At 3, it's at negative 4. 2, 3, that would be right. Negative 4 is not right. It's going to be negative 6. Let's see here. Try that one again. 3 in there, that would give me a 4. That 2. 2 times negative 3 is a negative 6. Minus 2 is negative 8. Okay? 6, 7, 8. Negative 8. Okay? If I go all the way out to 8, it's going to be at negative 11. So what is my graph looking like? It's looking something like that. Okay. Now explain. Why does it look like that? The negative 3 here in the middle. That tells you that I am flipped over the x-axis and I'm amplified over the normal one 3 times. This plus 1, that tells you I've moved 1 unit from the origin to the left. Okay? This minus 2 tells you I'm shifted from the origin down 2 units. So it's going to be right here. It's my beginning point, and it's 3 times bigger and amplified and negative at that point. So I explained it with this. I also found some points that we graphed. Okay? So let's look at another one. If I wanted to do this one, this time I'm not even going to try to come up with the points down here. You can do that on your own. I'm taking the cube root minus 1. That means I'm going to move 1 unit to the right. Okay? And I've got a plus 3. That means I'm going to move up 3 units. 2, 3, to right there. And then I'm going to have one that is half as big as a normal one. Well, instead of going through 1, 1, it's not going to go through those points. It's going to be half that size. It's going to be like this. And like this. Okay? Very, very skinny. That's the way you would sketch it. Now, in both of these, I didn't define the domain. In this particular situation, the domain is going to be all x values greater than or equal to negative 1. And the range is going to be all y values less than or equal to negative 2. Where are these coming from? Right here. See the 1? negative 1. Where's this 2? Negative 2. That's where you would get the domain and range. Okay, on this one, what would be my domain and range? My domain is going to be all x values. X is an element of the real numbers. And my range is going to be all y values. That is an element of the real numbers. In other words, from negative infinity to infinity. And from negative infinity to infinity. Cool? Going on. So, given an equation looking, a graph looking like this, which one of these two do you think it is? Well, not seeing a left side over here on this side, it's going to be a square root function, isn't it? Just like that one. Now, I can't figure out the a just by looking at it, but I can see that it's not shifted right or left, so my h is going to be 0. Okay? I can see that it's shifted down 2 units, so my k is going to be a negative 2. And so what I'm going to have is that I'm going to have a f of x is equal to a square root of x minus 2. I can now take either one of these 2 points. It won't matter which one. So I'm going to take the bigger one there. 1 is equal to a times the square root of 9 minus 2. I'm going to add the 2 to both sides, and I'm going to get 3 is equal to a times 3a. Well, if I divide by 3, a is equal to 1. I suppose you could say that this is plus or minus 3 here, because it could have been a negative 3 that I was looking at. But if I divided by negative 3, it'd be a negative 1, and my graph is not in the negative direction down there, so I knew a had to be a positive number. So writing my equation, finally, f of x is going to be the square root of x minus 2. Let's try that again, Mr. Green. I want to see how that's done. Well, this one, I can see has a right side and a left side. That means it's going to be the cubic root. I guess it could have been a fifth root too, but they're saying it's either square root or cubic root. Okay, I can see that it's shifted up 4. So k is going to be equal to 4. It's not shifted right or left. It's right there on that thing. So h is going to be equal to 0. So I'm going to take my bigger point again just because I like that bigger point. I don't know why. 6 will be equal to a times the cube root of x plus 4. Subtract the 4 from both sides. 2 is equal to a times the cube root of 8. Well, the cube root of 8 is 2, right? So 2 is equal to 2a. A will be equal to 1. Okay, writing my equation then. F of x will be equal to the cube root of x plus 4. Now, I would really recommend that you guys take your calculator at this point. You press y equals, and you actually key that in. X, and we're going to raise that to the cube root. That's 1/3 power. 1 divided by 3. Okay, we move forward. Plus 4. And I'm kind of suspecting that when I graph that out, I'm going to get the equation that looks just like this one right here. My zoom is off a little bit there. And to check this out, I would do a second graph and look at my values here. Whoops, I'm way off there. So scanning down here a little bit. At 8, my value was at 6, which is exactly the point I was expecting to get to, 8, 6. And at 0, my value was 4, which is exactly the value that I was expecting to get right there. So that must be the 2 points. That must be the graph. Ta-da. Okay. I do appreciate you guys when you're sending me K-mails that you're telling me that you're in Algebra 2. It really does help me find you quicker and respond to your questions quicker. So I'll look for you next time. Bye.